Hi, my name is Mingguk Kang, and today I will be presenting our work Distilling Diffusion Model into Conditional GANs. This research was done with colleagues from PostTech, Adobe Research, Seoul National University, and Carnegie Mellon University. What is diffusion model distillation? To explain, imagine you want to generate a single sample using a pre-trained diffusion model and DDIM sampler. We start by sampling random noise from Gaussian distribution. This noise is given to the pre-trained diffusion model, generating one-step denoise output like this one. Then we can do this process again to get more clear output and repeat this denoising process over and over until we get the clear pixel images. DDIM sampling usually require 20 to 50 steps of denoising process to get a single sample, and in practice, it is very time consuming and expensive. The purpose of diffusion model distillation is to distill a pre-trained diffusion model here into a student model, which is a blue network, making the student model generate a single sample with just one or a few steps of denoising inference. Then the next question will be, how can we achieve diffusion model distillation? Luman et al. Answered this question and presented a foundational method in 2021. The process is quite simple. Let's say we have a pre-trained diffusion model and sample random Gaussian noise like this. Then we can simulate these noises using DDIM sampler to obtain their OD solutions. And this noise and OD solution pair, which are essentially generated samples, are pre-calculated before training the student generator. Then the student model learns to predict the target OD solution from the given Gaussian noise using mean square error. Although the distillation process looks very promising and simple, this method was not adapted for recent text-to-image distillation method due to bad performance. As a result, alternative distillation methods such as InstaFlow and DMD has been proposed, and direct regression distillation is no longer commonly adopted for recent distillation models. However, our research found that the direct regression distillation is actually really effective and can be extended to text-to-image diffusion model distillation. From now on, we will focus on text-to-image diffusion distillation. In this case, the pre-generated dataset includes noise, corresponding latent, and text prompts. Similar to Roman et al.'s approach, we train the student model using regression loss. However, a key distinct in our method is the type of regression loss. Through empirical observation, we found that perceptual loss is actually very crucial for efficient distillation training. Here are some results. We found that using perceptual loss, especially LPIPs, significantly improved the one-step distillation performance. Using mean square error, the FID score was over 100, but after switching to LPIPs for regression training, the model generated much higher quality images. However, LPIPs pose concerns about GPU memory usage, training time, and decoding error, which we will discuss in the following slide. Let's look at how LPIPs is calculated. We start with two latent that need to be compared. These latent need to be decoded using stable diffusion decoder to obtain pixel images. These images are then fed into a neural network to calculate perceptual distance between them. This process takes 117 milliseconds and uses 15 GB of GPU memory. The high GPU memory usage attributes to decoding high-resolution images for LPIPs calculation. However, our proposed E-latent LPIPs use differential augmentation first to prevent adversarial attacks and compare perceptual similarity directly in latent space, speeding up LPIPs calculation by 9.7 times. Now, we will switch it to latent LPIPs. Since our regression training can be seen as a paired image-to-image translation, where source is Gaussian noise and prompt, and the target is OD solution, we can further introduce a conditional GAN formulation to improve distillation performance. Specifically, we propose a multi-scale input-output diffusion discriminator, and please refer to our paper for more details. We compared our distillation method, diffusion to GAN, with previous models like GAN and InstaFlow. Our model demonstrates better image synthesis quality and high frequency detail compared to the baseline models. We also compared our method with concurrent models, Stable Diffusion Tobler and Lightning, and demonstrated better image synthesis quality and text-to-image alignment. Here is another example. Thank you for watching. Please visit our webpage and paper for more details.